All right. So hey guys, I'm recording now. Okay? So the rules that I'm going to teach you today apply only to salts, so things that are made between a metal and a non-metal. And it is, again, absolutely critical that you have that sucker out and that you have this out. Okay? So for today, we're going to work off the sheet. The reason why I'm asking you to memorize those polyatomic ions is because then next week I need you to work from memory. All right? Because it's not convenient to always go back and refer to the sheet, right? So these two things need to be out for the rest of the lesson. We're going to start by naming things that do not have transition metals. And we're going to start with binary salts. All right, so we'll number this rule number 1. So binary without transition metals. And let me give you a bunch of examples of what I'm talking about. So I'm talking about things like MgF2 or CSI or Al2S3. So what qualifies these things as being binary without transition? So what does the word binary mean? 2. All right. So 2 what? Well, there's 5 atoms there. 2 different elements, right? So that's what binary means. So they have 2 different elements. And what I tell some students to look for is just look for the capital letters. Do you have 2 different capital letters in the formula? It falls under binary. And then if you look at the position of the first element on the periodic table. So we're going to grab our periodic table. I'm going to put it down here. Zoom back a little bit so you can see the whole thing in its full glory. Light up a little bit. All right, so magnesium, where is it? Is it right there? Transition metal? No. What about cesium right there? Oh, you can't see my finger. All right, down there. Is it a transition metal? How about aluminum? Is it a transition metal? All right, so it's 2 different elements. The first element has to be in either the S or the P block. Right, exactly. And how did I come up with these formulas? Like, why is MgF2, why is there 2 fluorines for every 1 magnesium? I crisscrossed, all right? Let me give you the names of these things and see if you can figure out the pattern, all right? This here, MgF2, is called Magnesium Fluoride. And this thing here, this next one, is called cesium iodide. And then the last one is called aluminum sulfide. How did I name them? What'd you see me do? Do you see numbers there? What's the pattern? I just added I to the end, right? I took the name of the first element. I took the root of the second element. And I simply added "ide" on the end. It is for these. For binary things, it's always "ide" at the end. Okay, so then let's practice this. This is easy, right? All right? Guys, so I'm going to give you 5, and I'm going to give you a minute on your own paper, see if you can come up with the names of these things. The first thing you should do is, number 1, check that they're binary. Number 2, check that that first element is in the S and the P block. And if those 2 things check out, then you can name them. What is that, Emily? Does it matter how many of each one there are? Nope. Why doesn't it matter how many of each one there are? Why don't we have to put that in the name? Because it doesn't change. It's always going to be those ratios, and those ratios are dictated by the charge. So you don't need for someone to tell you in the name. So you don't call this trilithium mononitride, right? We don't do that for this. You don't have to. Those subscripts are determined by the charges. All right? And I didn't do that in the prior examples, did I? Did I use anything in the name to tell you how many there are? Completely unnecessary. We don't have to do it for this. All right, so give it a minute. Where? It's RBF. Yeah, it's RBF. All right, so what's Li3N called? Whoa, 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 whoa. Be very careful. I heard a lot of T's in there. Lithium. Be careful, guys. Look, it's not nitrite. Nitride. Be very careful. It's not nitrate. It's not nitrite. It's nitride. All right. How about SRO? Strontium oxide, Na2O, sodium oxide, RBF, rubidium fluoride, Mg3N2. Oh, all right. Awesome. Awesome, awesome. What's that? No, you don't have to capitalize. We are in a little bit. All right, let's do ternary things. And again, we'll focus on things that don't have transition metals. Let me give you an example of what I'm talking about. So like, for instance, MgCO3 or NaNO2 or K3PO4. All right, so what does ternary mean? Well, 3 or more, okay? So they have more than 2 different elements. Or if you choose, look for the number of capital letters. Because I don't want you to think that, for instance, this has more than 2 elements just because you add the subscripts and that gives you an answer of 5. I'm talking about capital, like total different types of elements represented in the formula. So capital letters. No. All right, let me give you the name of this first one and see if you can figure out how I came up with it. So this first one's called magnesium carbonate. And then the next one is called sodium nitrite. And then the next one is called potassium phosphate. How did I name them? Is that just because it's got oxygen, I just automatically put 8 on the end? What did I do? Where did I get the first part of the name from? Okay, it's just the name of the first element. Okay, but where did I get those names from? What's that, Zach? And so where did I get the names from? I just memorized them. Right? So the second part is the name from the chart. Yep. And that's why I need you to memorize them. Alright? It's just the name from the polyatomics chart, period. You have to memorize that table. That's why it's so critical. Alright, so we're going to practice a few. What's that?
I thought there would be like a way to remember it.
No. You just have to memorize the table.
I know that
Okay.
now, but I thought that there would be another way to remember it.
No, babe, I wish there was. Alright, so let's do a few here. Okay, so the first one that I'm giving you to practice is a little tricky. Alright, see if you can figure it out. Easy money? Okay. I like to hear that.
I want to get a 0 and I put my sentence that way. And I make fun of you for saying easy money out.
Alright, so let's look at the first one, guys. NH4, is that a metal? No. Is it on that table that I just gave you? What is NH4 called? Ammonium. And then what is that element called? Bromine. So how do we finish off the name? Bromide with a D. No, you don't reverse it. You always read it in the order that it shows up in the formula. All right, what about the next one? What's that element called? This is lithium phosphite. And what about that next one? Sodium sulfite, yes? Yeah, so when you write these formulas, you always put the positive charge things first. Yes, ma'am? You finish them off in "ide" if it's not something that comes off that table. It's the default ending. Okay? Is this tough? No. All right, let's go backwards. Okay, so let's go backwards. Sodium sulfite. Ites with an I-I-T-E. What's, Emily? let's go backwards. Okay, so say I have calcium oxide and I have to go backwards. All right, so they're giving me the name and they want the formula instead. What do I do? I take calcium and I know what? It's Ca with what kind of a charge? 2 plus, and then I know that the second element in that is oxygen with what kind of a charge? 2 minus, and then what do I do with these ion formulas? You crisscross and reduce, so what do we get? CaO. So what do we essentially do? You wrote the ions, right? And then you crisscrossed. All right, let's do another one. What if I had to come up with a formula for potassium phosphide? What do you do? And what's the charge on potassium, Sam? It's on the first column. It's K1 plus. And then phosphide, what is that? If it ends in "ide," am I just talking about the element for the most part? All right, so what element is that? Phosphorus. What's the charge on phosphorus? 3 minus. And then once I write the ions, I crisscross. What do you end up with? K3P. Excellent. Let's do one more. What about aluminum sulfide? What's aluminum? With what charge? And what's sulfide referring to? Sulfur with what charge? 2 minus. Crisscross, what do we end up with? S3. All right? Okay, let's make it a little harder now. Bless you. Magnesium cyanide. All right, so what's magnesium? With what charge? 2 plus. And then what's cyanide? Well, beats me. Where can I find it? On my chart. All right, so cyanide, where is it? Cn minus. All right, so Cn minus. All right, and so now we're going to crisscross with a polyatomic, so what do we have to do with it? Parentheses, and now crisscross and reduce, what would you end up with? Mg, parentheses, Cn, parentheses, 2. Let's do another one. Aluminum hydroxide. What's aluminum? Al, 3 plus. And hydroxide, what's that? OH negative. And today you're looking on the table, but next week you need to have that memorized. Crisscross, what's our final answer? Al parentheses, OH parentheses, 3. All right, one last one. Calcium sulfate. That's calcium. What's the charge on it? 2 plus. What's sulfate? SO4, 2 minus. Look at the signs and the values of our charges. What do you notice? They cancel, so what do I do to get the formula? Just shove all the letters together, you get CaSO4. Okay? All right? Any questions at this stage? Listen, I have 5 minutes. I want to try to do transition metals with you. Okay, that's where things get a little bit tough. All right? Now, you have some homework to do in the book. All right? And so, it's, what's up on the board, Number one, you need to actually memorize those polyatomics, and then you have questions to do on pages 275 to it's questions 12 to 17. If for some reason I don't finish with the transition metals today, try them, but don't get too upset if you don't get them. Okay, we can always pick up at this particular juncture on Tuesday. All right, so let's talk about transition metals now. The naming, if there's a binary salt with a transition metal, and actually we may as well just go ahead and do binaries and ternaries with transition metals at the same time. So we'll call this salts with transition metals. Is not much different than what we've been doing up until now. There's just an extra little thing that we have to add to this. And so maybe I should give you an analogy to help you understand like why we do this. So anyone know who George Foreman is? He's the grill guy, right? George Foreman was actually a boxer before he invented that stupid grill. All right? He was a boxer. And George Foreman had, like, I think 8 children. You know what he named them all? He named them all George. All right? I think he had girls, and I think one of them was called Georgetta. You go look this up. I'm not making this up. He named all of his children George. All right? So imagine what Thanksgiving is like at that household, right? So everyone's called George Foreman. So how do you, right? How do you distinguish one person from the next? All right. So you have a different middle name, right? And so when we have transition metals involved in the formulas, we're going to have to add middle names to these things. All right, so let me give you an example. Guys, I've got 2 minutes and you're interrupting me. All right, so for example, say I've got to do these 2 substances that form from iron and oxygen. Because remember what we said about transition metals when we were doing electron configurations the other day? They can have more than one form. They can have more than one charge. Well, when iron combines with oxygen, you can either do it this way or that way, and those are 2 completely different compounds with different chemical and physical properties. All right, well, how do you distinguish between them? Because if we use the rules that we just laid out, you would think this is called iron oxide, and this is called iron oxide as well. And then at that point, they become indistinguishable. The way that we do it is we put Roman numerals in the middle. So this is actually called iron 2 oxide, and this one here is called iron 3 oxide. All right, so where does the Roman numeral come from? Sam? Well, you know where it comes from? Undo the crisscross. What are the ions present here in Fe2O3? It's Fe3 plus with O2 minus. What is the charge here on this iron? This is a combination of Fe2 plus and O2 minus. And if you don't get that today, that's fine. We can talk about that on Monday. This Roman numeral here is the charge on the metal. All right? So the Roman numeral is the charge on the metal. So iron 3 oxide has the formula Fe2O3 because it's iron 3 that is being used. Iron 2 oxide is a 2 because the iron that's being used here is the +2 version. Okay? All right, so let's stop there because the bell's going to ring. Do your best with those questions that I gave you. All right? And we can always pick up from this point where we left off.